All right, day 4 notes. This is properties of logarithms, and I'm going to tell you this is very important, right, for future lessons here. You have to know all of these properties. So please put every effort in to make the next few sections that much easier. So the first property is basically pretty easy. Anytime you do the log base of log base any base of 1, you know it's going to be 0 because the only thing you can raise any base to get 1 is 0. Anything raised to the 0 power is 1. Property 2, log base a of a. That's just going to be 1 because a to what power would give you a? That's just 1. So these are pretty straightforward. Now, property 3, if I do log base a of a to the r, look what happens here. If I write the exponential form, a to what power would give me a to the r? Well, what is that going to be? That's just going to be r. So what this is basically saying is anytime if I have a to the r, and say I want to get rid of this base a, what I could basically do is take the log base a of this, and that would just give me r. Okay, and that's what you're going to see we use here in a few sections. So when I do log base 0.2, right, so my base is 0.2, and then this is 0.2, right, this kind of wipes that out and just leaves me with negative root 2. Okay, the next property is if I take a to the log base a of m, okay, what is that going to give me? If you think about it, it's going to give me m. So here's what you need to understand is if I were to basically take the log of both sides here, right, what happens is the inverse operation of log base a is taking that log and taking a and raising it to that log. So basically, this wipes this out and leaves you with that. So when I do 2 to the log base 2 of pi, this 2 wipes that out and leaves me with pi. Now, property 5 is an important one. If I have log base a of m times n, what I could do is I could take this log and break it up into 2 logs. I could do log base a of m, but then I can go ahead and add log base a of n. So when I look at this example down here, letter A, log base 5 of 25x could also be written as log base 5 of 25 plus log base 5 of x. So these would be your logs. Letter B, I have natural log of e plus natural log of x. All right. Now, if I wanted to do the opposite and take the sum of these 2 logs, right, and write it as a single logarithm, what you have to understand is 1, you look for the sign in the middle, but you also have to have these bases match up. Since they do, addition means u and v were multiplied, so it would be log base 5 of u times v. Over here, right, my bases match up. They're linked by addition, so I know it was multiplication that was broken up. So it would be log base 4 of 6 times x plus 3. Okay. The next property, all right, log base a of m over n. Anytime we do this and break it up, if this is division, we end up subtracting. So it'd be log base a of m minus log base a of n. So right here, remember, natural log is the same as log base e, but we can keep it as a natural log. So we're going to say the natural log of x squared minus the natural log of x minus 1, all cubed. over here, this would be log base 3 of 4 minus log base 3 of x. Now, if I wanted to write as a single logarithm, I recognize the logs are linked by subtraction. So that means these were divided. So it'd be log base 3. This is going to be my numerator. So root x over, this is going to be my denominator, x. Now the last one is if I have log base a of m to some exponent r, what I could do is bring that r out in front, and it'd be r times the log base a of m. So right away, if I look at this one, I could rewrite this as bring the 3 out in front, so it'd be 3 log base 4 of x. If I wanted to write this as a single logarithm, now I'm going to keep it as a log. I'm not breaking it up. It'd be log base 5 of x to the third, but I have to bring this exponent up and raise that to the second. Well, what do I do with the exponents when I raise a power to a power? I multiply, and it'd be x to the sixth. Okay, so those are the 7 important properties that you guys have to recognize. So right away, if I go to simplify this, when we do this, we have to completely simplify. So first I have to recognize if I'm expanding or condensing, and we'll talk about condensing in a minute. Right away, log base a of this times this. So I know it's multiplication, so I'm going to break this up as log base a of x plus log base a of the square root of x squared plus 1. But what you guys have to remember is the square root is the same as 1/2 power. So this can be rewritten as log base a of x plus log base a of x squared plus 1 to the 1/2 power. Now you should recognize this can come in front. So my final answer here, log base a of x plus 1/2 log base a of x squared plus 1, and I am done. All right, next one, natural log, I have division, so now this is going to be subtraction. So the natural log of x squared minus the natural log of x minus 1 to the third. But if I recognize I have exponents here, I know I have to bring those down and out in front. So this would be 2 natural log of x minus 3 natural log of x minus 1. And you are done. For right now, this is probably over the top, so I'm going to skip that one because I don't want to make this video any longer than it has to be. Right? But I do want to get to now write each expression as a single logarithm. This is also known as condensing. So we recognize our bases are the same, and this is addition. So you know that this 7 and 3 were linked by multiplication. So we're going to say log base a of 7 times 3, which would be log base a of 21. Example 2, you have natural log, this is subtraction, but the thing is, when I have this number out in front, I have to bring it up. So that's going to be the natural log of 8 squared minus the natural log of 5 squared minus 1. So this now will become the natural log of 8 squared is 64 over 5 squared is 25 minus 1, which would be 24. And you are done. Okay, remember the subtraction tells you this is division. And the last one for this set. If I look, addition, addition, subtraction, right? So right away I know this, this, and this are linked by multiplication. And then I'm going to divide by that. So I'm going to have log base A of, I'm going to go 9 times x squared plus 1, right? All over 5. And that's how you would write this problem. Okay? Now when we look at this third example here, it says if log base 2 of 5 equals this, log base 2 of 6 equals this, log base 2 of 14 equals this. If I wanted to evaluate this, if I look at 5, 6, and 14, can I break 30 up into a quotient or product of any of these numbers? And I could actually break this up into log base 2 of 6 times 5. Now if I do that, now I can say that that's log base 2 of 6 plus log base 2 of 5. And right now, if log base 2 of 6 is, that is equivalent to 2.585 plus log base 2 of 5 is 2.3219. And if you go ahead and add those together, 2.585 plus 2.3219 gives you 4.9069, and we are done. Now, this one, if I have log base 2 of 36, I could actually write this as log base 2 of 6 squared, which means I could take that 2, bring it out in front, and say 2 log base 2 of 6, which would give me 2 times, what is the log base 2 of 6? 2.585, and right away, 2 times 2.585 would give me 2 times would be 5.17. Okay? Now the last one here, right? Log base 2 of 150, I'm going to do log base 2. Now 150 is 5 times 5 times 6, right? Because 25 times 6 is 150. So this is actually 5 squared times 6. So I'm going to break this up into 2 log base 2 of 5, because I'm bringing that out in front, plus log base 2 of 6. So I'm basically doing 2 times 2.3219 plus 2.585. So 2 times 2.3219, and then add the 2.585, gives me 7.2288. Now I could if I wanted to, go ahead and evaluate these on the calculator. So what I would do to do this on the calculator, right, is I would go to math, I'd go up to log base. For the base I would put 2, and then 30, and that would be your answer. Okay? Now, if this is on a non-calculator portion, you have to know how to break it up by properties. Go ahead, try the homework, and let me know if you have any questions.